So that's our basic Smith chart lecture. Let's review the things that you've learned. You've been able to plot the reflection coefficient, most often in polar form. We very rarely use the real and imaginary form in practice, although you can imagine it or see it on the Smith chart. In the polar form, what you're looking for is the magnitude of the reflection coefficient and its phase, and you simply read that off the correct circle and line on the Smith chart. The transmission coefficient T is 1 plus the reflection coefficient. That we also look for in polar form, so we get a magnitude and a phase of the transmission coefficient by reading off the correct circles and lines. The impedance, typically we're looking for the impedance at the load or the impedance at the input, and we like to be able to go back and forth between these two calculations. We can do that by looking at a picture of our transmission line and realizing if we have Zn and want to get ZL, we're going to be moving towards the load, and if we have ZL and want to get Zn, we're going to be moving towards the generator. That's what rotating or moving distances towards the generator or the load means. Always draw your picture so that you can see an arrow that really reminds you which direction you need to be moving. The admittance, like YL, is 1 over ZL, and that is found by translating through the Smith chart. So you look at the center of the Smith chart. If you happen to have Z on one side of the center, you have Y on the opposite side. So the admittance and impedance are found by translating through the center of the Smith chart. The voltage standing wave ratio and the location of Lmin and Lmax are typically used to help us find the load when we have measured the standing wave ratio and Lmin, Lmax. It's also reasonable to plot the load and be able to say what the voltage standing wave ratio is. Remember, the voltage standing wave ratio is a constant circle like this, like a protractor circle inside the Smith chart, and we read it off this axis right here on the right. The location of the voltage minimum, Lmin, is on the left side. Lmax is on the right side of the Smith chart. I'm going to make one more reminder, and that's about the open circuits and short circuits. The impedance of a short circuit is right here on the left. The impedance of an open circuit is on the right, and that is reversed for the admittance. The other really important place that I didn't really talk about is the matching point, and that's right here at the center. I'm going to put a smiley face on that one. That's the location where the characteristic impedance of the line and the characteristic impedance of my load or input or whatever I happen to have there are matched. The standing wave ratio would be 0, and that's a point that we often are seeking. So I hope that you have found the Smith chart a useful tool. It's a particularly useful tool when you do measurements and are able to see the results on the Smith chart. In the next set of lectures, we're going to be talking about how to use the Smith chart to match our circuits, how to be able to match something like an antenna that's not 50 ohms to a transmission line or a generator that is.